photographs of the finished building. Not too different from the perspective that I showed you early on. Okay. And because, of course, we accommodated for a percentage of the works to be done using conventional and DfMA methods, we can still have so-called non-typical components where you can have spaces like roof gardens and have unusual geometries. You have a little bit of unusual geometries at the podium levels in the landscape deck. Okay. Then we move on to application to housing. So for us at PNT, we were also the first consultant team that had the opportunity to work on a public housing project in Singapore, apart from HDB. Back then, HDB would basically design all the public housing flats in-house. So we had the fortune of being the first to be given the opportunity to design one as a private consultant. And this is a project built in Tampines. I think if many of you are probably born in the 90s and the early 2000s, so your parents who probably would be familiar with a sitcom sometime in the 1990s, I think, or the 1980s, which was apparently set in this apartment block. It was shown on one of the Chinese Media Corp channels. Okay, so interestingly, so almost 20 years after 1992, so let me just go back. When we designed this, you can see that it's actually got a brick facade, and our current managing director was still an architect when he was working on this project, and he would tell us stories of how they would actually use manual drafting and try to modularize the placement of individual bricks to accommodate pipes that would have to pass through the bricks for things like drainage, rainwater downpipes and such. So they basically had to manually draw how each brick would be placed, how to accommodate the pipe as it basically, so that you basically can seamlessly allow pipes to go through the pattern of the bricks as it was drawn manually. Fast forward almost 20 years later, so in 2009, we actually decided to go into public housing again, and we entered a design competition to do a housing project in Punggol. So today, most HDB projects still use this method of construction. Basically, you use conventional means of doing your columns and your slabs, and then you basically precast the facades in controlled factories and like in 2D, and then basically you mount them onto the facade. You mount them onto the facade of the building, which is why many of the newer flats actually have generally the same profiles, because these are actually standardized components. So that you can make the fabrication and the construction much more efficient and economical. Okay, so when we were working on projects like Punggol Sales, the general arrangement in terms of workflow, because I understand that as you do this design competition, you guys are going to be working in multidisciplinary teams. The general workflow was that you basically had a group of guys who did the architectural design. So you think about urban design, site planning, space planning, and so forth. Then you have a bunch of guys doing the engineering, so civil, structural, MEP, and so forth. And then you basically go back and forth. This is a love-hate relationship in real world. But essentially, you function as a consultant team. And then you take a package of drawings and you ask a contractor to tender for it, and then basically bring it to construction. So this is one of the traditional methods of procurement and working in real practice. But fast forward from 2009 to 2014, we were asked to participate in a design and build tender for HDB to do a project in Bukit Batok, West Terra. Okay, this is the first time PVC construction was ever used in a public housing project. Okay, and apart from that, we also basically used mass engineered timber for the first time. Okay. So this time the arrangement was different because we were basically working hand in hand together, the architects, the engineers, and the contractor working together, developing the scheme, the architects thinking not just about the design, but also having to think about the considerations of the engineer and how it will play out also for the contractor. So you're basically forced to think several layers ahead of what the process is going to be like. Okay. So the words of Henry Ford, coming together is a beginning, staying together is progress, and working together is success. Okay. So this is what we call in the office, we call this generation one of our journey into PPVC construction. Sorry. Okay. So the way we designed the site, this is a site plan, was we basically placed the commercial facilities on the site and basically faced it to the road because, of course, shops, eating houses, and so forth need to have commercial frontage. And then the idea that what we did was we basically took 2 layers of residential blocks and we splayed them open so that at the heart of the site, you basically have a meeting point, which is basically the main central green of the site. Okay, and then we placed another multi-story car park at the edge of the site. Okay, so this is what the launch brochure looked like. Okay, and so the other thing that we also needed to think about was to, because we were working with the contractor, was to try to design as many identical blocks as possible. So the idea is to basically have blocks that repeat themselves so that you can basically, they're basically a repetition in that sense. And on top of that, we also had to decide up front which type of construction would be used for which block and how the contractor was going to manage the logistics of construction when they're going to move forward. So in this case, all the blocks here highlighted in red use prefabricated bathroom units. So basically the whole bathroom is hoisted into place as one component. And then the blocks that are highlighted in blue use PVC construction and PBU together. So you notice that we actually also designed them, all the 3-room flats and the 2-room flats. It's basically the blocks with the 3-room flats and the 2-room flats. Partly because we wanted just to try it and we weren't very, very sure if the housing board was going to be open to the idea of using this system. So it was sort of a guinea pig and we were in a way taking a risk and in a way potentially jeopardizing our likelihood of winning the tender if it was a scheme that the housing board ultimately didn't like. So we were lucky enough, it was something they appreciated and wanted to try. Now, what we did for Bukit Batok is what we in the industry call an N-shaped system. So basically, an N-shaped system is you basically have walls and you basically have the slab of the unit directly above you as part of one component. That's why in section it's an N. So you basically see the 3D components on the right-hand side here. Okay, so basically you have walls, you have the facade, we have the window built in, and you basically have the facade of the floor of the unit directly above you. And the idea is you basically piece them into place and you basically use wet pour to stitch all of these components together. This is our first attempt. Okay, so of course, this is what it looked like when you assemble them in blocks. The drawings are actually extracted from our Revit drawings. Okay. This project was also the first time we used mass engineered timber technology. So we actually used this project as a guinea pig for it. It's a technology that I'll talk about a little bit later on more elaborately using a bigger project. But it's actually this one, as we applied it in Bukit Batok, it's a small building. It's basically just a drop-off porch with an RCC located at the back. So this is what it looks like using mass engineered timber. This is also a form of DfMA. And the thing about this, and what I'll do is I will play the video. Okay. See if it will load. It's not playing.
I have to go to the
Okay, maybe I'll just. Will it play? Okay. Okay, so this is a time-lapse video of this whole building being constructed. It's going to take 3 minutes to play through. But one of the things that we actually considered when we were designing this building was, of course, the timber is imported from Europe, from Austria, actually. So one of the things that we considered was that how to avoid allowing the members which are imported from Europe, so basically they're members that have been adopted to European weather, to avoid ground contact. So what we had to do was we actually had to build the entire building on a concrete plinth, which is why all the floors are in concrete. They're basically raised up, and each member is actually sitting on a bedding, a concrete bed, and they're actually hoisted into place. The timber actually have natural notches, and you basically drill them into place. And this is what it looks like as you're basically constructing the whole building. Okay, the roof is still cladded over with composite panels. The roof is all still cladded with composite panels. So if you just notice the way as the floor plan is coming up, Areas such as offices, bathrooms, and such are actually built into the back of the building facing the drop-off porch. And the main working area is actually one big open space that we have sliding doors that just opens up straight to the landscape. That's kind of like how we planned it. And then here we have a covered linkway that is basically attached to the entire building. And later on, you'll have one big roof that's basically on top of the whole thing. Okay. From here, you can see the members, the large timber members being installed. This time-lapse video was taken over the span, I think, of about 6 weeks. So it's how fast this thing can get built. Okay. Then you can notice waterproofing is applied as a layer above on the roof and actually some of the wall surfaces, because what we basically tried to do was we wanted to avoid direct contact with the rainwater coming through, but we still cladded the entire building with another kind of timber, not necessarily the mass engineered timber that we basically used for the structure of the building. So thus, when you walk into the building, all the floors, all the walls are actually using this form of timber technology. Okay, I think I'll skip through the video and okay, so here we still have waterproofing. Before we apply the timber cladding on the edge. Okay. Okay. Next, of course. This whole process of using PVC and DfMA actually ties in very, very nicely with the use of BIM, because you have to coordinate all of your different services together with each component. You cannot be, it'll be very, very difficult to do on-site improvisation of punching holes for utilities and services. So basically you need to use BIM upfront to basically establish and look for detection, we use software like Tekla, for example, to basically work out clashes between services in M&E and CNS and architectural members. Okay? And subsequently, we also use this to allow the contractor to do their construction planning and implementation on site. So this is Gen 1. Gen 2 is a site in Yishun, okay, which is the first time we basically began using what we call a U-shaped PPVC system. So we talked about designing for place or designing for people. So this is the site as in 3D. We found out that URA was actually planning to do a bicycle path. There's actually a plan to do a cycling path at the opposite side of the street. So thus our idea was to basically create 3 entrances, 2 of them for vehicles and 1 of them for pedestrians. And then basically link the 2 entrances, have community facilities such as child care center at the heart of the site so that they can open up to the central green space. And then we wanted to basically mark the entrances as gateways. So that's why we actually tilted the blocks in a manner that when you arrive, the blocks are shaped to basically receive you as you enter the site. And of course, another thing that we thought of was that because the site was very tight, there was not a lot of space on the ground, we wanted to create another layer of recreational spaces directly above. So we thought it would be a great opportunity to activate the areas on the roof garden of the multi-story car park, and also allow people to enjoy views out. So thus, the idea was to create a series of bridges. And some of them would be garden bridges, like the perspective that we saw earlier, and then basically link them all such that every block has a direct opportunity either through the adjacent block to basically reach the roof garden of the multi-story car park. Okay, so this is basically what the first story looked like. And this is basically what the typical floor looks like, where even if you live in the block furthest away from the multi-story car park, you can basically, from your lift lobby, have a community living room in the sky, cross a garden bridge, and basically walk to the roof garden. So that's the idea of what we're trying to do, to basically link people up and create another layer of public space for people to enjoy. But when we started to look at how we were going to do this, for those of you who are familiar, I'm not so sure, HDB actually gives us a list of prototype unit plans that we must follow. So most of the flats that are being used in public housing come from a so-called catalog that architects have the opportunity to adjust maybe 10-20% of it. So what we tried to do was to take those unit plans and try to see how they can be modularized using PPVC construction. So thus we basically created what we now use, refer to as a U-shaped system. A U in a section in the sense it comes with the walls and it comes with the floor. And what happens is that each component comes with a protective roof, so that when it is hoisted on site, you can still basically have protection for the flooring of the unit. So this is what it looks like, the individual components. Okay, and then it was here when we were designing the 4-room units of this for this particular project where things started to make sense for us. We started to learn lessons that we told ourselves, okay, I think we know how to take this further for the next project. But the way it works for the 4-room is that basically this is how the 4-room is constructed. You have the unit directly below it, and you basically hoist the entire kitchen into place, hoist the 2 bathrooms into place, hoist the household shelter into place, the master bedroom, common bedroom, second common bedroom, the living dining room, and then after that you just pour the concrete, stitch them all together to basically create one unit in itself. So this was actually the first time that we began to use this system where we were able to basically include finishes in the entire process. Okay, and then here it is also with this project where we started to use virtual design and construction, VDC, where the idea is to basically have us, our engineers, this is our CNS engineer and the MEP engineer, work together. Each one does a BIM model. You basically put them through a grinder, okay, and then you basically have all your clash detection sessions. And the idea is to basically create a virtual mock-up. Now, I'm sure most of you guys have mobile phones, okay? So then we have basically what we call integrated concurrent engineering meetings. So you basically have to check attendance and make sure everybody's present. And basically there's a lot of fighting and quarreling happening during these meetings. Please move your beam this way. Please allow my pipe to penetrate. Please shorten your wall. Please allow my outlets to come here. So there's a lot of, you think people are cooperating here, but basically there's a lot of quarreling happening during these meetings and negotiation. Now I'm sure most of you have your phones. The objective of the ICE meetings is to basically create a virtual mock-up. So if you actually use your phones and use the QR code to actually take this QR